Good afternoon and welcome to today's webinar. You will be muted during the webinar, but if you have any questions or comments, please use the questions section. We will answer your questions at the end of the webinar. The webinar is recorded, and in a couple of days, we will send you the link to the recording. The topic for today is AI-powered systems engineering reuse. My name is Cecilia Karlsson, and with me I have Juan Llorens, CTO at the Reuse company, and he's today's presenter. So let's start with a few words about the Reuse company. What do we do? The Reuse company offers a platform and a set of well-defined methods to support the implementation of an incremental and comprehensive reuse process. The approach is based on knowledge management and elicitation, quality assessment, interoperability across tool ecosystems, artificial intelligence, and smart search engines. Our presenter today is Juan Llorens. Juan has been a systems engineering professor at Universidad Carlos III de Madrid until May 2026. He has been collaborating with us for a long time, and since June, he will retake the CTO position at the Reuse company. Juan got a PhD in industrial engineering and robotics in 1996. Juan is a member of INCOSE, and he has the CSAP and ESAP certifications. So let's take a look at the agenda for the webinar. We already had a short introduction to the company. And then Juan will introduce a systems engineering reuse. Next, he will talk about the reuse process and methods guided by AI. We will see some demos, and we will learn how to implement a reuse process. And finally, we will have some time for Q&A. So let's start with today's topic. Hello, Juan.
Hello. Thank you very much, Cecilia. Can you hear me?
Yes.
Okay. Thank you very much. Let's start. Nice to have you all here in this webinar. My intention is to present not extremely in depth the reuse process, systems engineering reuse specifically, do some demos also, and try to explain a little bit how can you guys implement one of these processes. So here's a little bit what I'm going to do. Cecilia just very well made it. Let me start with a very, very brief approach of reuse. Of course, with this name, you can imagine that reuse is specialized in offering reuse. Okay, basically systems engineering reuse. Our attempt of solving this problem has been since the beginning to perform artificial intelligence, although in the 90s when reuse was created, it was not so extremely easy to do artificial intelligence. Basically, we were doing natural language processing more or less in the way, less than more, of course, in the way the LLMs are doing it right now. But we were trying to do that because we needed to understand natural language text. So that's what we still do now, empowered with our own technology together with the LLMs and new generative AI. So we try to offer systems engineering reuse by combining quite a lot of things, as Cecilia said before in the introduction. But basically what we try to do is to create an integration hub, to create a set where all the information that you produce can be in a way treated just by managing the same type of information. Instead of trying to solve your problems at requirements management systems or problems with model-based systems or CATIA or whatever, try to create a hub where everything is connected to. To this hub, we can start providing quite a lot of things, particularly, for example, AI. And then we can offer solutions to the classical technical management processes that affect the technical process in the ISO 15288. Quality, risk management, decision management, traceability, and so on. So that's a little bit what we try to do. Let's start very quickly with a definition of systems engineering reuse. You can imagine, you can read it there. I'm not going to read it there, but I like very much the notion of Dr. James Martin, who defined a kind of methodology along the traversal between process, methods, tools, and environment. Of course, enabled by technology and people. This approach, I think, is quite nice to define a systems engineering reuse process, because it, in a way, tells us what kind of things this process must have, methods, tools, and environments, and all that. So a classical reuse process in the 90s, when we started with it, is always being affected by at least 4 different layers. The first one, when I was just studying as a student software reuse, was named by the support of the program. We need the managers to support it, and it was extremely important at that time. Then you, of course, need the process, where you just define the what, okay? Then you, of course, clarify the way to do the process or the how just by defining a set of methods, and of course the tools must come just to enable everything. In our case, as we are reusers, natively we have to think of connecting to your existing ecosystem of information, because otherwise we would not be reusing. So the environment for us is extremely important. It is whatever ecosystem of tools that you use in your daily work. It can be whatever, okay? It can be the PLM, it can be MBSE tools, it can be Office tools, it can be whatever that you guys do. And theoretically speaking, we should have to be able to connect to whatever you guys use, so that we can start providing reuse capabilities. So the process itself, let's start. It is, I think it is quite simple to explain. The process has several activities, but I hope that you will follow me if I just tell you that these 5 activities comprise very well what is the notion of reuse. Okay, the first activity, which doesn't have to be the first to be done, but the first clearly activity is to identify reusable assets. Without assets to reuse, you are not going to be able to reuse anything. Okay. The second one is necessarily to qualify these assets, because if you don't reuse good quality elements, then I think that it is going to be a bad approach for you to do reuse. The third one is when they are qualified, then you have to take control of them. You have to classify them in a way that they can be then reachable. The fourth one is the key element in reuse, just to adapt. And I tell you the key element because most of the people clearly don't make the difference between reuse and use. Okay, so you don't reuse your car every day you go to work. You just basically use. So in order to reuse, you have to do kind of transformation adaptation. Okay, so it's quite important. And the fifth one in whatever process is, of course, to measure. Let's put this a little bit more in easy words. This webinar is not intending to go into deep approach, but just as first layer of description of reuse. Cecilia has asked me to get in depth in further webinars, just explaining a little bit more technology. But in this first webinar, I think that we are going to go fly over the whole process with not trying to seek too deep into it. So let's go and explain it. I have whatever elements probably made in the past. You see there are some aircrafts, and the identification section or activity on reuse needs to, in a way, identify which candidate elements can be reusable. Okay. The qualification one is the one that makes all these elements or assets or artifacts or engineering items, as you want to call them, make them as enough quality to be then further reused. Okay, so you can measure the quality based on CCC approach, correctness, consistency, and completeness. You can measure it in different other performance, whatever qualification aspects. You can trace them and create good relationships between them. You can give it values and whatever. But the next step, when you have already qualified these elements, are to classify them. And usually this implies preservation or persistence. There are several ways to classify them. The most typical way in reuse is just by using metadata. You metadata all these elements to be reused later on, so that you can use the metadata information to create a search. There are more modern ways than that, but this metadata is the classical one. But at the end, what we have to do is we have to be able to retrieve the different elements that I want to reuse. And I'm meaning retrieve because if you know something that you already want to reuse, that's okay, that's good. You just go and take it. But this is a kind of ad hoc reuse and not a holistic, systematic one. The real systematic approach means that you can reuse, you must reuse things that you don't know that they exist. Adapt. There are many ways to adapt. I will show you later on, but basically what we have to do is once we have found something, we have to do something with them and not just basically use it, okay? In this case, you can see that I am just playing with the colors of the wings so that at the end we can produce something that is completely different than what we were initially looking for, but it has been made by assembling different elements. And it doesn't have to be the system itself. It can be the modeling. You can do reuse of different models. You can do reuse on different requirements. If you have templates, you can do reuse of whatever, all the different aspects. Finally, of course, once you have just done that, it seems to be quite interesting in whatever process, the PDCA. Okay, so you have to measure in order to improve what you can do in the future. Few more slides on process, and then we will get a little bit more deeper in the methods. So for us, reuse must be part of the B model. There are many people that like the diamond model, which you put in front of the virtual and the real, but we dislike that. We think that this is much more nice to still have the V's all over the place. So you can see in the first left side under the composition and definition, this is classical decomposition part, where you just decompose the system into more advanced and specialized elements. In the right part, where you integrate and do the B&B from the right to the left. There's a lot of B&B done in left to left, but it's in the standards, is put this right to left B&B. So we simply, in our approach, we put the virtual world close to the real one, as you can see there, and in between all of them, that's where we put the knowledge, the database, knowledge base, the assets elements, and AI to collaborate and work with them. That's a little bit what we do. Okay, then don't forget the validation, but it doesn't give any value in this presentation. Okay, how does all this approach embraces the system lifecycle? We like this slide. It's a kind of matrix. You can see in the columns the different domains that exist along the system lifecycle development, by the way, but also you can include it in the production, in the fabrication, in the maintenance and service, and the commission. So all the different aspects along the life cycle are columns there. And then in the rows, we like to organize everything in the following way. Down there, you get the connectivity section. You have a lot of tools in the bottom row, and then on top of it, we because of reusers, we like to call this concept of synchronized source of truth. The source of truth is always in the databases that are managed with the source tools. But if we want to provide services on this information and reuse, we like the notion of synchronized source of truth. It synchronizes ours with the real one, with the real source of truth that exists on the main tools. On top of that, we provide artificial intelligence. We give a layer where artificial intelligence can start working from there upwards. So the next one we like very much to call technical management processes, and we put them all horizontal, as you can see, including B&B, because we think that they must occur along the whole system lifecycle and not only on the system side. Of course, when we have all this qualification and management and everything that we just put in the reuse process, on top of that, you can put a search engine, which is able to work with all the work products that exist below. This search engine allows us to find and identify whatever work product or engineering item that we can then try to adapt in one way or other. Okay, we can do interoperability and reuse in order to produce a life cycle. First approach with our tools, here they are. I'm not going to mention them because I will mention them later on. Let's go a little bit on the methods very quickly. Identify what is it that we can do if we AI power the systems engineering reuse. What can AI do for identifying work products? It can do a lot of things. There's something that AI does very, very well when data is unstructured, which is it just identify terms, identify more or less relationships, breakdown structures, glossaries, and it has quite a lot of power in order to organize the information. So we like very much to use AI in order to identify elements. To qualify, we can do quite a lot of things, and people tend to rely on AI tools to do qualification, quality particularly, not bad, but it doesn't have to be necessary to use only LLMs to do this qualification, because they usually most of the times are not deterministic. They fail, they change the judgments over the time. Quite not nice, but combining them all with deterministic ones could be done. Probably you guys know all of our products, RQA, which are deterministic AI, and then combining this with LLM could work quite well. Number 3, classify. Of course, there in the classification part, there is quite a lot of things that can be done with AI, but particularly in the retrieval one is where I think it is much more interesting, because with all this RAG and CAG, it could be enriching the queries and combining all these AI or let's say LLM power, artificial intelligence for retrieval, combining this with structured information in an ontology or knowledge base makes a very, very, very good approach. To adapt and transform, AI is very, very good in transforming structured models. So if there's something it usually fails less, is when you do transformation of models. So of course, AI can help quite a lot in adapting, and measuring doesn't help a lot. Indeed, I should recommend not to use AI for measuring, because you have to have good values and not completely blown ones. Okay, so the next slide I put here is just basically getting you guys closer to methods. Probably you don't read them, okay, because they are in very, very small letters, but it's not necessary for you to read them. The only thing I want to put in here is that once we have decided the process, which is identify, qualify, classify, blah, 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 there are methods that are applicable to all these different activities. For example, in the identify section, why don't we think of identifying acronyms automatically and creating a glossary? Why don't we think on trying to find similar requirements in order to get templates that then can be instantiated as a way of reusing, and so on. So there's many, many things that you can do there, and I just put them in this first light blue color in the column. In order to qualify, of course, there's quality management, V&V digitalization, configuration management, traceability works quite well. AI helps, in my opinion, very well with avoiding the blank paper syndrome. So even if they don't give proper information, it's good to get this information in order for you then to remove this, which is wrong. It gives you quite a lot of ideas, and at the end you perform very well with a lot of nice productivity. So traceability, probably many times it doesn't work so well, but it gives you information that can help you then to decide later on. Security digitalization, IP digitalization, you anonymize automatically models if you need, and so on. There's quite a lot of things in the qualification aspect that can be done with deterministic or with LLMs. In the classification section, there are at least 2 main sections. The first one is to index or to structure the information inside the repository, and the second one is to retrieve. Okay, here in the index one, there are some attempts to do this automatically, and we have been working on that, trying to extract automatically the information that then can be put into the search engine in order to be retrievable. Adapt. Okay, here comes the stronger part of reuse. Of course, you can reuse by search, looking inside a place and find an own. I find that and I own it. you do data reuse or information reuse. Data reuse, of course, when you just, for example, visualize all the different information from all the different connections of all the different source tools that you have in just one repository, in just one web page. This could be data reuse, even if it's visualization. Information reuse, basically to transform information through interoperability. Patterns or templates reuse, product line engineering, or even knowledge reuse, just much more high-level aspects, like it helps you to do authoring, smart authoring, by just asking you to follow different templates or patterns. Functions reuse, by the way, most of the times forgotten, but function reuse is quite nice. Your tools, the ecosystem of tools you have, provide a lot of functions. For example, there is a very nice compiler of UML or SysML v1 in Rhapsody. Why shouldn't I use it if it is much better than the one in AI, for example? Then I take the information in AI, I put it in Rhapsody, I use the function of compiling it, and then the result I send it back to the user in order to change the AI models, okay? So then, of course, prompting, which is a way to do a reuse, of course, and then many other applications. Reuse, as I told you, anonymization, IPL calculation, and so on. And for measurement, I don't spend a lot of time. You should measure everything, okay? So here is a list. I'm not going to name them. I give them here. If you're interested, when you receive the video, just can stop here the video and take a look at them. But here's a list of many proposed methods that describe possibilities of you guys to do reuse just without having to create a huge problem, okay? So very quickly on our tools, very quickly. It's not the goal of this webinar, but I want to show them a little bit about these tools. Okay, here is the core of our approach. Here is the systems engineering reuse process. So we provide a triangle of tools, 3 tools. Then there's quite a lot of flavors on them, but there's 3. The first one in here. The first one is the SES Engineering Studio, which is the desktop tool, which is the core of all the applications that we provide. The second one is the portal or the web tool, which is a tool that allows us to do quite a lot of services, not all, on a web-based approach. So you can connect to get the information from the connections, you can do traces, you can see quality, you can do quite a lot of AI on it. And the third one is the batch server, which is the one that enables you to operate and man all the different activities that you want. If you want to calculate the quality, then you can make a batch server, run it under the weekend, and then get the results during the next day. So basically here, everything that we provide in here is based on this triangle, okay? And here you get the different tools that are, once I have shown you the triangle of the engineering studio, then the different tools are those tools. This is the engineering studio is here, the engineering studio is here, the engineering studio is here, and the portal is here, and is here, and is here. Okay, so you can get access to the different tools from the different activities from the different tools, so the web and the portal. Okay. So let me name them very quickly. Here's Knowledge Manager for managing information that has been collected. RQA, probably you know them all from the past. The search engine, interoperability tool, we call it Interoperability Studio. It is running in here, but we call it Interoperability Studio, and then the measurement one. Besides, we call it SES AI, which you will see now in a second, which is our AI capability. And then we have Acquisition Studio, RAT, and MBSE Modeler, which is a SysML v2 tool. Okay, this one, I leave it here for you also, for you understanding a little bit more what is it. Don't worry, I'm not going to go through it. I am more interested in just showing you some demos and then how to implement the reuse process and go into questions. So There's a lot of demos. Of course, you are not going to see them all because there are many, but I'm going to name them some. And just if we have time, I hope that we have time. I'm going quickly in order to have some time for questions. So we can come and show you other things. But my intention is to go into creating connections for identify, to see that how can a tool identify terms, patterns, relationships, breakdown structures, and so on very quickly. Then I have been choosing the possibility to see for you RQA, but not in the classical RQA that you guys have been using in the last 10 years, but now RQA running in metrics that are connected with LLMs, okay? Here I'm going to show you, this is going to be the desktop tool. This one is going to be the desktop tool. This one is going to be the web tool for you to see a little bit. And these three will also be desktop tool. Okay, this will be reusing data. We're showing you how to see all the connections. And then you will see a little bit how can you, through connections and information, you can find things. And finally, I will go back again to the desktop in order to do measurement. But here you can see many other things. How AI, every time you see this icon here, this pipe and this hat is representing our SSAI. Okay, let me start a little bit for you that don't know how this works. Let me start a little bit very quickly showing you how do we connect to things. Okay, so I'm going to go quicker in order to win more time. Okay, sorry, here it is. Let me show you first. Okay, a little bit more here. So this is done on the desktop, and you can see in this screen that we connect to different tools. You see there are some different connections, and what we want to do is now create a new one. So what we are going to do is create a new connection, and there are several tools, I don't know, 40, 45 or whatever. This guy is using now IBM Rational Doors, and here this window is the unique window in the whole platform that is specific for each one of your tools. So in order to connect to Doors, we need to have a specific window, but the rest of all the windows are completely common to all the different connections. Okay, so at the end, once this information has been produced, a new card will be created. We are going to, I am trying to show you always the same example. Sometimes I will fail. It is the temperature warrior. It is a use case, practical use case that we use here in reuse here in order to do all the operations and the demos. The temperature warrior is a physical system that controls the temperature. So once we have just done that, we connect, and then we get the information inside the platform, and that's enough. The only thing I wanted to show you now is that we connect things. The second one, I'm going to go quickly on that. The second one is the way we could now put LLMs in order to extract information from whatever connection. Okay, now I'm going to show a Word document because it seems to be easy. This is the desktop tool again, and now we are configuring the LLMs to use. There are many, many LLMs to be used. Okay, so the possibility is that we adapt to the LLM that you guys have inside if you want, or that you want to connect. If it is inside your own facilities or if it is public, we don't really care. So basically what you are going to see here now is that there are several choices to choose. You see, in this case, you can select the possibility to generate terms, to generate clusters of terms, the terms that represent the same information or similar, relationships and the type of breakdown structures, associations, or whatever, patterns of textual patterns to be used in RQA, or even metrics for RQA as well, to generate metrics, okay? So this guy, what he's doing is producing selecting several of them. It has been selecting all of them. Now it's creating the different sources to get the information from. In this case, it's a Word document, and run. What it happens here below is that all the prompting is done internally, and then, of course, what happens is that it spends quite a lot of time. In our case, this guy was using Oyama. Oh, sorry. There it is. This guy was using Oyama, and it is just basically telling you what kind of things happen, and just running and running and running, extracting information. Sometimes it gives you good information, some others doesn't give you good information, but again, at least what I think is best from LLMs is that many times it can work, and it gives you some data where you can just use it as avoiding the blank Baker syndrome. Okay, here you get all the information that has been coming from the LLM, and then you can just inject it into the database, or reject that one, or even in the future modify all these elements and so on. Okay, clusters that has been created with all the different terms and so on. Okay, go a little bit quicker. I think indeed, I think that it is quite a lot, quite enough what I wanted to show. This is Knowledge Manager for you guys. This is the tool that manages the ontology and the terms and everything that we have created with the LLM. I leave it here. Let's go into RQA now, which is basically the way to use now the elements that we have injected in the database, the names, the terms, the patterns, the clusters, and the measures, and the metrics, and so on. So let's try to use them, continuing using the quality framework that was produced in RQA. I don't know if you guys are used with RQA from the past. I don't know how many of you are there connected, but then you get new metrics. Okay, so these metrics are LLM metrics. So you are able to put your own metrics. If you want to put your own prompts, that's perfect for us. There's no big problem. At the end, you will have your deterministic metrics running with your non-deterministic metrics. Okay, there you see count the number of verbs or shall verbs. Okay, that was quite a stupid prompt, but you could eventually inject there what you think that is interesting for you in order to analyze the quality. The result is merged with the rest of the metrics so that it provides you another value, another way of measuring. In this time, sometimes, for example, quite a lot of people just say, I want you to measure the quality based on the INCOSE guide for writing requirement rules. Okay, that's enough. Then the only thing that LLM does is just use the INCOSE guide for writing requirements rules and provides you the results. Okay, so you can see here how this is just working and running in there. And the result at the end is, of course, this LLM producing information inside the RQA framework of results, including the evolution of the quality that we manage and provide in RQA. Okay, let me see. Well, yeah, a little bit more. The RAT for you guys. The RAT, I don't know if you remember, the RAT is the authoring tool that the Engineering Studio provides. Okay, it just allows you to write and edit and modify and create elements based on patterns, guided by patterns, and controlling the quality on the fly. Okay, so now you see here again this icon, which basically means that now in the RAT you get, of course, now the choice to use LLMs for whatever you would like. You have the context with this, which is the requirement, and then of course you can do whatever you would like on the RAT, like rewrite the requirement based on the intentions or the results given by an LLM. Okay. Okay, so here it comes and provides you quite a lot of information. INCOSE rule number 9 is good or is bad, is managing the quality, but this is also everything given by the LLM itself. Okay. I'm going to finish that one. And I am going now towards the portal. Okay, so we have just connected, we have just created information, we have just connected to the requirements or calculated the quality of the requirements based on LLMs. Now, let's try to do something which is finding information inside the repository. So now you see this is a portal, this is a web-based tool. Here you get the same connections that you have just produced in the desktop tool, and here you have a search engine. You can provide stronger or weaker questions, okay? But at the end, you get results from all the different working elements that exist, okay? So in this case, this is a doors requirement Somewhere is Excel information. Up there is managed temperature increase, which seems to be a function in Cameo, and so on. Okay. Once you get this information received from the indexing of the different connections, you can of course now start navigating through it, seeing, watching what the information is, or tracing, checking the impact analysis based on traceability that has been discovered, will be discovered later on also on the AI tools, and so on. Okay, so this guy is showing you filtering activities, and a little bit more closer here, then you can get some information. Let me show you again. There's something that is quite nice. You see here again the icon of our AI. So that basically means that if you just want to do it, then you can just call AI LLM and start working at the context that you want. Okay, you can work at this level element, or you can do whatever. You can see their traceability or quality management activities and so on. Okay. Let me go a little bit quicker. Okay. Here is showing you a little bit what I was telling you before. You can see here the impact analysis, and you can see or navigate through the impact analysis and check or extend and expand all this in a global impact analysis and so on. Okay, so I'm done. Let's get now into the adapt one. Okay, so I summarize connecting to information, doing some identification, qualification of information, finding elements. Now let's try to do things. The easy one, the first one, is we call it reuse data, which basically means that in one platform, you can see all the information. And we call that a reuse of data. You have all this information, and then what we do is just change the context, because you have the information on your source tools, but instead of that, we provide you one unique way of visualizing all the information, besides the notion of producing traceability or whatever. You can now, I don't know, send this for a review to somewhere else, because you don't need to, let's say, provide a huge, difficult environments with Cameo or Enterprise Architect, Rhapsody, Capella, whatever, in all the different tools to open models. Okay, so you have one place to be able to see all the information. Of course, you can do management of it. You can change information, but this data reuse was basically on the notion of visualizing. You can modify things, but it doesn't have any meaning if you have a Cameo model or an Enterprise Architect model to do the changes in here, because the MBSE tool is an editing tool for models, and this one is just basically a tool for visualizing and doing traceability. So we are not as good as they are in order to do editing with graphics and whatever. We have other tools for doing that, but not this one. Okay, you can see here, this is visualizing the Cameo model from the same platform that you are being visualizing requirements. Okay. Let me show you here. Here you get some interoperability. In this case, interoperability between Enterprise Architect and Cameo. Here you see some authoring capabilities, as you have seen a little bit here, but now on the web tool. Here is a logical modeling. This one could be interesting. Let me show that one. I'm not going to do this navigation. Let me show you that one. And then the other one was to reuse functions. So quite quickly, what this guy is doing now is, let's create a kind of coach for you. Okay, now we are going into our SES AI. It's basically our environment to connect AI with the rest of the connections of your ecosystem. Okay, so this guy is creating a notebook. If you are aware of the Google Notebook, this one is the same. It's a notebook with the same structure. The only difference is that the sources are connections to your tool ecosystem, so you can have connections to different things. Okay, so in this case, this guy have just connected to a requirements system, the classical control temperature variable requirements. You have a lot of possibilities here. You can see you can do the mind map, or you can do a classification, rewriting. You can do check the quality, calculate the quality. But in this case, what this guy is going to do is he's just going to ask the LLM about if it can produce an architecture of the requirements. Can you produce an architecture of the requirements? And the LLM says, oh, of course. The LLM always will say, yes, of course, absolutely. Here it is. And then this is a candidate architecture just texted. The next one is just to say, okay, can you? I think he just asked if it is possible to get more detail. Oh no, he was asking for a visual diagram, but the LLM didn't understand. So it just made a detailed description of the architecture. So the next one just was defining these possible or different possibilities to create a diagram. So this guy asked to create a diagram here, and then after the rest of the information, he just said, I want you to create XML text. Okay. So there is. So please use a formal UML, and then this guy, the LLM produced a formal UML, and then asked it, could you provide a XML v2 text, and the LLM produces XML v2 text. Okay, what to do? Send this XML v2 text into the source tool that we want, the Cameo tool, and then in order to extract or operate properly what has been produced, which probably is rubbish. Okay, done. I'm going to leave this measurement because I'm a little bit running out of time, and I want just to at least be able to talk a little bit. So then make some questions and answers. So how to implement a reuse process? If you remember, we were talking about all these different activities that happen to do. Let me put the three of them here. The ideal one would be where the manager and the leaders are sponsors, the processes are clear, the problems are identified, the methods are selected, and the tools are operating properly. In reality, it says ideal. I've never seen that. The first one, where the management want to provide a reuse approach, is almost never seen before. Okay, as well. And the practical one, which is the one I have seen in my career, is the one that is the leaders say okay, but they don't really support economically. They don't just say okay, let's go and make some investments in that. The process is not fully clear, but the systems engineers dare to go. The problems are clearly identified, and the methods to solve are well known. The tools are ready to help, and the leadership probably jumps on the horse running by the systems engineers and says, okay, just go and try if it doesn't cost too much. So in this notion, that's what we offer most of the times, is instead of just spending huge amount of money just sponsoring from the top large project, let's go and try to create a reuse process by solving normal problems, classical problems that you guys have every single time when you do your operations. You need to assure the quality of the requirements. You need to create glossaries. You need to maintain traceability matrices all over the different tools. You want to connect models with requirements. You need to implement a change management approach for the global set of tools. You need to transform models into simulation environments. You need to create test cases automatically. All those are your standard daily problems. So why don't you just basically, instead of solving them by yourself, solve them by yourself, but just thinking on the reuse approach? That would imply that you can work very quickly in what your problem is. For example, I want to manage the quality of my requirements. Okay, this is your task. Okay, once you do that, once you get this information connected, let's try to create something inside the ontology or the knowledge base. And once you have done that, measure a little bit. And once you have measured, just ask the search engine to index this requirement that you have qualified, and then suddenly you are able to reuse. And the same 4 other aspects. You need to find information. Okay, then find the information with the search engine and everything. Once you have the information found, try to put your tools in order to extract the information, measure again, calculate the quality of your work product that you have already indexed here, and get into reuse. Or even, I need to do interoperability. Okay, no problem. Interoperability, is that what you need? Okay, that's number 1. Once you do interoperability, classify all this information into your search engine, and then at the same time, try to get the commonality there. Once you have done it, measure the process and go into quality as well. So there's one more slide. The problem solved unit, the PSU, is the way we try to offer all this approach, which basically is, do you guys would like to solve your problems at the same time you start a reuse process? If you want that, that's easy. You are not going to invest a lot because these problems are to be solved one by one in 2-3 person months, 2-3 months calendar. And the intention of that is, you have your problem, we provide you a solution with our tools. And once this solution is there, you get the second problem. But if you have a connection to, I don't know, you have your requirements in Polarion and you want to manage the quality of them, just do it. At the same price, you have already now the possibility to index these requirements from Polarion, and you can put them into the repo. And if you want that, you can also automatically use this information in order to generate your models and put them into, I don't know, Capella. And all that stuff just by starting with managing the quality of requirements in Polarion, and so on. Some documents for you in case you're interested. Please feel free to contact us. We can send you the proposals if you're interested. And my conclusions, quite quickly. This webinar has introduced the approach to a systematic systems engineering reuse in a very strange way, which is, don't go and ask for money to the managers. No need. Just solve your problems. Which problems you do have when you do systems engineering, solve them. But solve them considering that there is a roadmap when you solve the problem that allow you to solve other problems. And at the end of several PSUs, you suddenly have a complete reuse approach implemented in your organization. The reuse process that we have been mentioning are identification of assets, qualification, classification, adaptation, and measurement. And again, a bottom-up approach to reuse has been introduced by basically naming the notion of PSUs. I'm done, Cecilia.
Okay, thank you, Juan. Juan will answer your questions in a minute. So if you want to ask him anything, please write your questions in the question section. Yeah, we already have a couple of questions. So let's start directly. If I analyze the quality on requirements with another language, Spanish, Swedish, etc., and use the INCOSE guide for writing requirements, will this work with an LLM in SES?
Yes, absolutely. The LLM is quite strong in let's say, merging or working with the guides of writing requirements or with whatever, even if you put the information in another language. So my answer is, yeah, no problem. You can prompt the LLM to check the quality of the INCOSE guide for writing requirements, even if your requirements are in, I don't know, French.
Okay, thank you. You offer a set of tools to implement the reuse process. Can you explain why there is no need to replace the existing ecosystem?
Yeah, good question. Okay, so the intention is not to replace any single tool you have. Besides that, is to connect them. So the information exists in your tools, whatever you are using, even if they're old or new, even if you mix or mesh or have different tools. no problem. The only thing we have to do, and this is the restriction from our side, is we have to have a connector to your tools. If we have a connector to your tools, everything that exists in your original tool can be then merged with the rest of the information and can be then properly worked in the way to create traceability, manage the quality, transform the information into another information, and so on. So that basically means that the services that reuse offer are not replacing any single tool, neither PLM, neither ERP, neither MBSE tools, simulation tools, test verification tools. None of them are necessary to be replaced. The only thing that we do is just connect the information that they provide for you to do things.
Okay. Next question. You have explained the PSU as the means to implement a reuse process. I don't understand the concept properly. Could you please explain it more deeply?
Yes, absolutely. So the PSU, the name of PSU is Problem Solve Unit. The intention of a PSU is to define a problem that whoever of you guys have, to define a use case, which is the one that would validate at your side the success of the solution that we provide, and then we work together, our engineers in operating our tools together with the engineers of your side. In the case of special needs, we tailor the tools in order to solve the problems that you have. And the result must be verified from our side use case automatically with our automatic graphical user interface testing tools. And when you guys have implemented this inside your facilities and run it, then we just consider it validated when you say it is validated. So basically, at the end of the process, you have something that must solve your problem, whatever it is, whatever of all these problems that I show you here, whatever of them they are, they must be solved. And then once they have been solved, they get into production. So I don't know, imagine, for example, I can tell you some use cases that we have solved in 2025. There's one very large tier one that needs to interoperate between them and their OEM. And the OEM is using, I don't know what, I don't remember, but I think it was using some Cameo tools. The tier one was using Rhapsody tools. The OEM was using, I don't know, NAF or whatever architectural models, and the other company was using their own architectural modeling, and they need to interoperate. That was a PSU, and the result is an interoperability between both organizations that is put into production. The second, another case can be automatically generation of a particular ontology. When this one is solved, then it goes into production. Eventually, next year, the company that produces that one decided to do for something for I don't know, a particular way to share the models, but now not sending files, but just connecting between tools. So the problem now is to interoperate between a tool that exists somewhere in the planet and another tool with another environment with another model existing somewhere in the planet, so that they can do co-design. That basically means that one company in their own tool change models that are injected automatically in the other side's tools, different environment, or whatever. So once this one is produced, just get into production, evolving the existing ones, and so on. And then suddenly, after several years, they have now qualification of models, classification of models, and they can retrieve them, transformation, adaptation of the models, measurement, and so on. And then with this, when I told you about the ontology, then they were just creating an identification. So after 2 years, they have a full reuse process approach implemented.
Okay. Another question here. If I don't have to ask my manager for money, does that mean we can use the suite for free for a certain period?
Sorry, can you repeat the question because I didn't hear?
If I don't have to ask my manager for money, does that mean we can use the suite for free for a certain period?
I'm sure that the sales department in Reuse are going to say yes to your question. Yeah, I agree. It's not. It's not. The notion is not for free. The notion is instead of spending, I don't know, a couple of million euro or dollars in producing a reuse program in 3 years, instead of doing that, just you guys get, I don't know, the PSU normally tends to be around $50,000, 50,000 euro, a PSU one. So you ask for a couple of PSUs, then you get $100,000 euro, and then during the PSU you get all the tools. And I don't know if salespeople are here, just they can correct me now, but you get all the tools for free during the PSU, and then you can of course implement the process. And once, I think that the model that the salespeople do is once the PSU go into production, once it goes here, then is when you purchase the tools. But when you are doing all this stuff, there's no tool purchasing. It's for free.
Okay, then short one, I hope. I have seen a tool named Acquisition Studio. What does it solve?
Oh, yes. The Acquisition Studio is a kind of tailored requirement management system for big organizations doing procurement, ministries of defense, and so on. It is well used in the north of Europe, in the different ministries of defense in the north of Europe, because when they want to procure high level systems, I don't know, jets, aircrafts, or panzers, or boats, or all that stuff, the process of procuring is not so straightforward. They need to produce an incredible qualified set of requirements. They need to have good requirements because otherwise they were going to die. So they need to do qualification, RQA, and so on. And then they share those requirements and they start negotiating. So all the process of negotiation of the requirements between the different bidders and the ministries are very specific. They need to share and they need to merge, they need to compare, they need to do trade-off analysis, and all this has been automated. Then the possibility to automatically create the best bid and avoid lawyers is also part of it. So it's quite a specialized requirement management system made for procurement.
Okay, thank you. So let's finish here. Thank you, Juan, and thank you everybody for attending. If you have any further questions or want to know what this approach can save on your current project, don't hesitate to book a meeting with our consultants or send us an email. If you want to try our tools, we will be happy to offer you a trial license. Visit our website reusecompany.com for more information and our YouTube channel at The Reuse Company for videos about our tools. I hope to see you soon again. Thank you very much and goodbye.
Goodbye.